Hi guys, hope you all doing well. So here we are going to analyze each and every question of CSIR NET November 2020 Chemical Sciences with best conceptual analysis along with extra information which may useful for you for your further preparation. So watch the video completely and click on like and do subscribe our channel for further updates, and if you are interested you can visit and join on chemmasters.online. Okay, now just look at the given question. The number of peaks with relative intensities observed in HNMR spectra of iron carbonyl at plus 30 degrees centigrade and at minus 80 degrees centigrade in diethyl ether ore. So simply, if you have the concept of fluxional behavior, so you can answer this question. Yeah, before that, just look at the given iron carbonyl where we can draw it in a cis form and also in trans form. So I'm just drawing its cis form, okay? CP. Right. Now, I'm just taking neutral electron count to decide the hapticity of the two CP ligands, because here we need to assume the given iron carbonyl follows 18 electron rule and it is stable. Okay, so in that case iron contribute 8 valency electrons, here D6 and S2. Okay, right, now each CO contribute 2 electrons and here we have 2 carbonyl ligands. That's why total of 4 electrons. Now it is equals to 12 electrons. Then how many electrons are required to make it 18? So simply we need to add plus 6. Okay, right. The 6 electrons must be distributed in between these two ligands. Okay, so here the possibilities are one of the CP ligand with neta 5 hapticity. That means this CP ligand coordinate with iron with its 5 electrons, and other CP ligand must be with neta 1 hapticity. Then it will fulfill its 18 electron acceptance. Okay, now just consider one of the CP ligand is coordinating with the iron with neta 5 hapticity and another one with neta 1 hapticity. So I'm just drawing it. So this is neta 5. Okay, it is coordinating with its 5 pi electrons. And now another one where it should coordinate with only one carbon. So here you can draw this neta 1 hapticity. We know that, so just look at a ring whizzing of simple the cyclopentadiene ligand. Okay, right. So whenever it connect with the metal, so here we have one hydrogen. So just draw all the hydrogens on CP ligand. So we can label the hydrogens based on their chemical environment. So just consider it is A, okay, and these two hydrogens are B because they are in similar environment, okay, and these two are in similar environment and just labeled as C. Okay, right. And here the metal migrate or shift to another carbon at a higher temperature that is slightly higher than room temperature. So we can say 1 comma 2 metal shift onto the neta 1 CP ligand. So it will continue on each and each carbon. That means after moving here, metal can move here and here and here like that. Okay, so at room temperature, the 1 comma 2 shifting of metal is very high. That means the rate of shifting is very high. So it is not easy to detect that where that particular metal is connected on that particular labeled hydrogen. Okay, so in that case it will give only one signal, one NMR signal. Okay, right. And if you look at the another one, neta5. So here these two CP ligands are in different chemical environment, because here the neta1 CP is connected with only one carbon, and whereas neta5 CP is connected with the pi loop. Okay, pi loop of that CP ligand. So that's why they are in different chemical environments. And neta5 ligand can also switch or can also involve in fluxional behavior. That's why at more than room temperature, neta5 CP ligand will give one signal, and neta1 CP ligand will give one signal. So here at plus 30 degrees centigrade, we can observe two peaks in HNMR. One is for neta1, one is for neta5 CP. Okay, right. Now at minus 80 degrees centigrade, what happens? Simply the ligands freezes at their positions. Okay, they cannot rotate freely. In that condition, we can say here for this simple what we say neta1 ligand, already we have labeled here. Okay, so just check them. So here is A, and here is B, and here C. Okay, so here we need to look at relative intensities of those chemically equivalent protons in that NMR signal. So we can see one is for the here 5 is for that neta5 CP. Okay, which is freezed, and the relative intensity is 5 for that neta5 CP. And then you can see for these protons which are labeled as C, we can get 2, and for these hydrogens which are labeled as B, 2, and for this hydrogen which is labeled as A, we can get 1. So the correct relative intensities at a freezed position of that iron carbonyl, we can get 5 is 2 is 2 is 1. Okay, so based on this we can conclude that option 1 is the correct answer. Okay, right, thank you very much.